this question, we're given a grouped frequency table, and we're asked to find estimates for the mean and the standard deviation for the data. And then we're asked to use our calculated values to determine whether there are any possible outliers in the data. So a two-part question here. Even though we're asked for an estimate, we are still doing an accurate calculation. It becomes an estimate because in between 6 and 7, there are 24 values. We don't know what they are. They might all be 7. They might all be 10. But we're going to make an assumption that they are all the midpoint of 6 and 11. We're going to make an assumption that they are all 8.5, or that they're all evenly spread within the interval 6 to 11. Either way of thinking about it, we get the same calculation by using midpoints as our data values. So this should all be able to go into your calculator. In list 1, we're going to set out all of the midpoints for this data. And in list 2, we're going to put in the frequencies. So the midpoints for each of these, you can calculate them by hand, or you can type them directly into the calculator. 6 plus 11 divided by 2. Making sure that 6 plus 11 is in brackets, and that gets you your 8.5, and will get you all of your midpoints for this data set. If you were to do that, we'll find our estimate for the mean and our estimate for the standard deviation. And now these values are on the calculator screen for you, 17.31 and 9.02. Again, if we're working with the mean and the standard deviation, and we've been asked to find whether there are outliers, we are using the outlier rule of thumb, x bar plus or minus 3 sigma. So x bar minus 3 sigma will let me know the lower outlier boundary. X bar plus 3 sigma lets me know the upper outlier boundary. Any values beyond these may well be considered outliers. So here's the calculation for the lower outlier boundary, and we get negative 9.76. If there are any values smaller than negative 9.76, they would be outliers. There are no values smaller than negative 9.76. The upper outlier boundary, 44.38. If there are any values bigger than 44.38, they would be considered to be outliers. Looking at the last interval, it finishes on 46, so there may well be outliers above 44.38. One of those 6 values might be 45. All 6 of them might be 45. All 6 of them might be 46. We don't know. So in our conclusion, we'll just say that there may be outliers at the top end. So just to formalize this, we want to make a comparison and make a conclusion. My comparison is that negative 9.76 is smaller than the lowest possible value in the lowest interval. So there are no outliers at the lower end. And 44.38 is actually smaller than the biggest possible value I might have in my data set. So there may well be outliers at the upper end. So those are my comparisons and my conclusions, and that's how you clear the marks on this question.